Welcome to Fresher Seed, and today I'm going to be showing you the best and the easiest way to read a structural drawing. In the description box down below, I've dropped the link to where you can download the structural drawings that we'll be using for this class. But if you don't feel like, I'm also going to be putting up all the drawings that I'm going to be using in the course of this video on the screen, and also I've divided this video into sections. So if you're more interested in the particular section of the video, there are time codes in the description box in which where if you click a particular topic, it will take you to exactly where it is in the video. So let's dive right in. How to read structural drawings. First, what is a structure? A structure are the parts of a building that carry load, either vertical load or horizontally. Some examples of building structures include the following. The foundation. So a foundation generally consists of the strip slash the walls, the pad or the column bases, columns itself. And this is for specifically for pad and strip foundation, which would be the kind of foundation that we're using for our drawing today. Yeah, let's go. That's number one, the foundation. Number two is the beams. Number three, staircase. Number four, floor slab. So please don't forget to subscribe to my channel, like this video, please, and turn on your post notification so you can be notified when I post new material. And if anything is unclear, if you have any question, do not hesitate to go to the comments. A structural drawing could be dimensioned using in to in, center to center, and out to out. If you require further explanation on what in to in, center to center, and out to out is, I've made a video on that. You can go and check it out. And a structural drawing is labeled alphanumerically. The vertical sides of a structural drawing is labeled numerically, while the horizontal sides or the horizontal strips of a structural drawing is labeled alphabetically, giving it an alphanumeric labeling system. So today we are going to be starting with the foundation as it should be. The foundation is a composite building element. This means that it is made up of different elements. And the implication of this is that it cannot be read as one element, and it can also not be measured as one element, because practically it cannot be constructed as one element. Different elements make up the foundation, so you have to treat each element as an individual. So we shall study each element individually. Column bases on the foundation layouts are represented using a square. All those square broken lines are the column bases, and the square black dots and the circular black dots within those square broken lines are the representation of the column. So whenever you see that, you know that's a column base and a column. The details of the column bases has been provided in drawing number 2, called pad foundation details in the drawings. This BT1 stands for base type, column base, and it is separated into types because there are different sizes of the column bases. And once the sizes of the column bases change, it means the specifications of the materials that will be used to construct it will change. So base type 1, there are 24 numbers, like 24 column bases. And the size is 1200 millimeter by 1200 millimeter. Base type 2, this is like a diagram of base. This is base type 1. We're just going to use base type 1 as an illustration. Base type 2, there are two numbers of base type 2. It is 13 by 13. Base type 3, there is just one of base type 3. It is 15 by 15. Base type 4 is 17 by 12, and it's just two numbers. There are a total of 29 column bases going by this statistics. But in practical cases, when you're in the construction site, it is best for you to go to the foundation layout and actually count the column base. A column base is made up of reinforced concrete. That's concrete with reinforcement inside it. So this 6Y 01 200B is simply a description of the column base, and I'm going to show you a very straightforward way to understand what it means. Now, look here, 6, this is the first, information. Y12 is the second information. 01 is the third information, and 200B is the fourth information. You can see it here. This is a 12Y. See, this is the reinforcement. 12Y 01 200B1. Here, 12Y 01 200B2. Then this box, like I said, stands for the column, but we're not dealing with the column now. So the first information, 6, number 6, the 6 is equals to the number of reinforcements. Like I said, a column base is made of reinforced concrete. The reinforcement size is to make it stronger. As you can see right here, the way the reinforcements are, they are vertical, there are reinforcement on the vertical axis and on the horizontal axis. I'll show you. Look at this column base now. You see, this is an horizontal axis and this is a vertical axis. There will be reinforcements here, you know, there will be reinforcement bars here, and there will also be reinforcement bars like this. This is the details of the reinforcement bars along the horizontal side. 6 stands for the number of reinforcement bars on the vertical. So on this side, you can see 6Y12, So Y12 here stands for the yield strength of the reinforcement bar or the diameter of the reinforcement bar. How do they get 6? Obviously, they got 6 because the engineer has specified the amount of spaces or the extent of distance or the extent of space that should be between each bar. That's a given. The engineer is going to specify. So we take the length in which the bars will be, which is 1,200 in this case, and we divide this by 200. If we do that, that's 1,200 divided by 200 will give you 6. Divided by 200 will give you 6. So that's how they got the 6Y. Y12 simply stands for the specification of the reinforcement bars that will be used to reinforce the column base. So 6Y12, this 01 is simply an ordinal number. And what do I mean by an ordinal? It indicates an order. Look here. If you look here, this is 01. I made a mistake. If you look at the drawing, here it's supposed to be 02. Let me correct it. 02. So it's telling you the order. You can see right here. So if you look at the drawing, there's 01, 02. And on BT2, if you look at that two, that the one with the 7Y12, 03. Continuing from here, like the vertical is 03, the horizontal is 04. If you look at BT3, 05 on the vertical, the horizontal of BT3 is 06. So it's simply stating the order. The only one that is different is BT4, which goes back to the beginning 0102. That's because it's a different type of column base. If you look at BT4, if you look at the details of BT4, you will notice that there are two columns. There are supposed to be two columns on the column base. So that is what 6Y12 01 200B1 stands for. It means there are 6 numbers of Y12 bars on for the number one side, and the spaces between them is 200 Now let's just do a couple of examples and move to the columns. Let's derive the details of this BT4. So the engineer has specified that the distance between each bars should be 200B, 200 millimeter, and the bars itself will be 12 yield strength or 12 diameter bars, reinforcement bars. So let's first get, this is 1, the vertical is 1, the horizontal is 2. So let's first get for 1 now. So What is the length? 17. So it means the bars, how many bars will be like this along 1700? How many bars? Let me just draw it out. So between each, there is 200 meter space. So that would be 1700 divided by 200. For what? For one. For length one, which will give us 9. 9 what? 9 y bars. So that would be 9y12 for what? Which number? 01. And what's the space that should be between them? 200. That be 200 what? B1. So it will come like this. If you check your drawings now, you see that it's the same thing. 9y12 be number 2 now. So that's how many bars will be along 1200. So it will be, you feel me? So that will be 1200. This is one, two. 1200. 1200 divided by 200, which will give us 6 bar required. So that's what? 6 what? Y12 bars for number 2, which is 02. Well, the space between them is what? 200 millimeter. 200 B2. And if you look at the drawing, that's exactly what's there. Look at BT4, base type 4, 2 numbers. That's how to read your column basis. So let's do the same for base type 2. And all this, they're in the drawings. So this is number 3, because I told you this is ordinal. This is from base 1, 2, 3, 4. For base type 3 is 5, 6. That's why I said this one is not 7, 8 because it's obviously of a different structure. So let's do for 3. Number 3 is what? 1300. So along 1003, there's also 200 B space. So that would be 1003 divided by 200, which will give us what? Let me use my calculator. Always use your calculator because once you put the right numbers in the calculator, it will never make a mistake. But several things can make you make a mistake if you're using your mind. That's the answer is 6.5. And obviously, there can't be 6.5 bars. We're talking about structure, so it cannot contain any kind of weakness. So we'll round it up to 7 numbers. Number required. So let's go. 7 what? 7y12. 7y12 or what number? 03 B 200 B1. So it should be here. You check the drawing, see 7y12 03 200 B1. So let's do for the other one 3. Since it's 1003, it will still be the same 7, right? Because add it up to 7. So same thing. 7y12 04 200 B2. Voila. So it will be here, 7y12 04 200 B2.